Grade 8 Mathematics, Chapter 1, Rational Numbers. Before knowing the definition of rational numbers, let us know few more definitions like what is a natural number, whole number, integer, rational number, irrational number, real number, complex number. So, what is a natural number? Natural number is also called as a counting number. When you are given a set of objects, then how will you start counting them? We'll start counting from 1, right? 1, 2, 3, like that we'll start counting. So, natural numbers are nothing but the counting numbers which begin with 1 and they have infinite numbers. Next one is a whole number. Whole number is a set of natural numbers included with 0. Means whole number will also be having 1, 2, 3, but at the beginning they have a 0 and so on, they exist till infinity. That is about the whole numbers. Here in the figure you can see that natural numbers are subset of whole numbers. Why? Because if you have taken set of whole numbers like 0, 1, 2, 3, here this set is also having natural numbers. So, we can say that natural number is a subset for whole numbers. Next one is integers. Integers are nothing but a set of positive numbers, 0 and negative numbers. We already discussed that 0 and positive numbers comes under the set of whole numbers, whereas if you include negative numbers to the set of whole numbers, it becomes the set of integers. Next one is about the rational numbers. Rational numbers are nothing but the numbers which can be written in the form of p by q, where p and q both are integers and q value should not be equal to 0. Those are called as the rational numbers. For example, take any rational number like 0.2. So, it can be written in the form of 2 by 10. So, p by q form we are able to write it, and here both p and q, that is the numerator and denominator, both are integers. As we discussed already what are integers, the set of positive numbers, negative numbers and 0 comes as integers. So, it is in the form of p by q, where p and q are integers and q value is not equal to 0. So, all the conditions of rational number definition got satisfied. So, the given number 0.2 is a rational number, we can say. Though he has given you minus 0.2, then you will get minus 2 by 10, where minus 2 is also a integer. Okay, so minus 2 by 10, that is minus 0.2, is also a rational number. If you take any mixed fraction like minus 5, 3 by 4, 5 4 5 are 20, 20 plus 3, 23, minus 23 by 4. Here this is in the form of p by q. Here p and q both are integers and q value is not equal to 0. So, this minus 5, 3 by 4 is also a rational number. Now, if you take this example, it can be written as 6, this is called as bar, okay, 4.6 bar. It means that 4.6 is having infinite number of times. So, we can even write this kind of numbers which are having bar at the top, those kind of numbers also in the form p by q, but how to convert them in the form p by q we will learn in the next grade, okay. So, here the numbers which are having bar forms will also come under the rational numbers, okay. That is about the set of rational numbers. Whereas the other numbers which couldn't be written in the form of rational numbers, that is which couldn't be written in the form of p by q, example pi value. Pi value can you write in the form of p by q? No, 1.414 so on will have its a value. We cannot write in the form of p by q, whereas as I gave you before example like 4.6 bar, when you have bar kind of numbers, that is 4.66, same number, when it is repeating, that kind of numbers you can write in the form of p by q, but this kind of numbers you cannot write in the form of p by q. So, the numbers which cannot be written in the form of p by q are called as the irrational numbers. Next one is a real numbers. The set of rational numbers and irrational numbers together is called as a real numbers, whereas the complete real number set is called as a complex number. Okay, this is the one diagram representing the number sets. Next, let us see rational number definition. Any number which can be written in the form of p by q, where p and q are integers and q value when it is not equal to 0, then the given number is called as a rational number. Even 0 can be called as a rational number. Why? Because see, 0 can be written in the form of p by q like 0 by 1. If you write like 0 by 1, its value doesn't change. So here p and q both are integers and q value is not equal to 0. So 0 is also called as a rational number. Properties of rational numbers. We have 4 properties of rational numbers: closure, commutative, associative and distributive. We are going to perform a few operations like addition, subtraction, multiplication and division on this set of properties, and we are going to find out which property is satisfying which operation. Okay. First one is a closure property. Let us take any two rational numbers, a and b. Now, when you perform addition, subtraction, multiplication or division to this set of rational numbers a and b, then the value which is going to obtained should be belonging to a rational number. Q is the representation of rational number. For example, natural numbers means we represent with n, whole numbers means we represent with I, integers means we represent with I or z. Like that, rational numbers we are going to represent with Q. Okay, so when you take any two rational numbers and if you add, subtract, multiply or divide, you should be getting the answer as a rational number only. Only then we can say that the closure property is being satisfied under that particular operation. Now let us see the first operation, that is addition. I have taken two rational numbers, that is 1 by 4 and 2 by 4. Now see, observe here we have taken like denominators. If you want, you can take unlike denominators and you can solve, no problem. So when I solved it, I got 3 by 4 as the answer. If you observe, this is considered as A, this is considered as B. We did addition for both of this and we got a rational number, means it belongs to Q. So this property of addition is satisfying rational numbers. Next one, let us see for the subtraction. 1 by 3 minus 3 by 5. Here if you observe, we have taken unlike denominators. Now let us see how you are going to find out 1 by 3 minus 3 by 5. First take LCM for the denominator numbers, you will get 15. Now 3 into 5 is 15. So multiply the same number with the numerator also. 1 into 5 it becomes 5 minus 5 into 3 you will get 15. So the same number you should multiply, means into 3 you should do 3 3 the 9. So the answer will be minus 4 by 15, which is a rational number. So observe here, when you are taking two rational numbers and subtracting, you got a rational number, which shows you that closure property is being satisfied not only for addition but also for subtraction. Let us take another example to find out whether it is satisfying for multiplication. Minus 5 by 7 and 9. 9 is also a rational number because it can be written in the form of p by q. When you multiply, you get a rational number minus 45 by 7. So multiplication is also being satisfied under closure property. Next is division. Dividing two rational numbers. Whenever you have given with dividing two rational numbers, then convert this division symbol into multiplication symbol. So the rational number on the right side of the division, it is going to get the reciprocal. See here 1 by 5 is given in the question. So it becomes the reciprocal, that is 5 by 1 we are going to write. 2 5s are 10 and 3 1s are 3. You will get a rational number again. Observe, when you are taking two rational numbers and when you are dividing, you got a rational number. So division is also being satisfied under closure property. If you see this table, the ones which are marked with green ink, those are called as a satisfied properties, whereas which are marked with the red ink, those are called as the unsatisfied properties. Here these properties under closure, addition, subtraction, multiplication and division, 4 of them are satisfying this closure property. Next one is a commutative property. For commutative property, we need two rational numbers. First, these two rational numbers you are going to take on the LHS side and take the same two rational numbers, but just interchange their values and then take. So a plus b and b plus a. For example, if I have taken a value minus 2 by 3 and b value as 5 by 7. So the answer I will get like 1 by 21 if I solve. Whereas this side, in the right side, what you will do is b value you will take first and add it to the a value, that is 2 minus 2 by 3. Then let us see what you will get. You will be getting the same answer, that is 1 by 21 only you will get. So both the sides, that is to the LHS side and the RHS side, when you get the same answers, then we can say that a plus b is equal to b plus a. This is called as a commutative property under addition. So commutative property under addition is being satisfied for rational numbers, we can say. Now in place of addition, just place subtraction symbol, that is minus symbol you are going to place. Now apply this negative, minus 2 by 3 minus 5 by 4, let us take. Okay, solve it. You will get some answer like minus 7 by 12. In the same way, 5 by 4 minus 2 by 3 you do. You will be getting the answer like 7 by 12. Okay. Minus of minus 2 by 3, a value is minus 2 by 3. So here you will get plus and you will get 7 by 11. Okay. So here you can observe that commutative property is also being satisfied under subtraction. For multiplication, the same method you will apply, it will get satisfied, and for division, the same method you will apply and it will not get satisfied. I repeat, for addition it will satisfy, for subtraction it doesn't satisfy. Okay, why? Because here if you observe minus 7 by 12 and here second one if you observe 7 by 12 will get. So for subtraction it doesn't get satisfied, for multiplication it satisfies, whereas for division also it doesn't get satisfies. Okay, just take any two numbers, perform operation again, interchange the numbers and perform the same operation. So if you get LHS is equal to RHS, then you can say that the particular property is being satisfied under commutative property, otherwise it is not being satisfied under commutative property. Let us see the table now. Again, see, I said you in addition it satisfied, a plus b is equal to b plus a you got, but in subtraction it did not satisfy, a minus b is not equal to b minus a, and in multiplication it satisfied, and in division it did not satisfy. Okay, now let us go to associative property of rational numbers. Associative property is nothing but you will be having a plus b plus c, that should be equal to a plus b plus c. Means take any three rational numbers like a value one rational number, b value another rational number, and c value the other number you are going to take. First substitute ABC values here, b plus c value which are in the brackets we are going to solve first. Okay, we know BODMAS rule, right? Always brackets first we are going to solve. So b plus c value you are going to get first, then add that value to a. Again this side, in the RHS side, what you will do, a plus b value you are going to solve first. Why? Because those are in the brackets. So the value which you got will be added to c. Okay, so in this way when you do, here you can see this example, 1 by 2, 5 by 2 plus 3 by 2 we have done. So when you do it, you got 9 by 2, whereas 1 by 2 plus 5 by 2 when you have added and added the result to 3 by 2, then you got 9 by 2. So in both the cases you got the same answer. So we can say that in addition this associative property is being satisfied, whereas in subtraction you will get different answers and it is not being satisfied. In multiplication again you will get the same answers, whereas in division, let us see how we got. See, 1 divided by 2 divided by 3, what you did, 2 divided by 3 is there, no, 2 by 3, that one when you convert this into division symbol then it becomes multiplication symbol, so 3 by 2 you get. Okay, again 1 divided by 2 here divided by 3, so how you will solve 1 divided by 2, division symbol when you convert into multiplication, what happens for 3, it becomes 1 by 3, you will get 1 by 6, both are different answers. So we can say that in addition it is satisfied and in multiplication it got satisfied, but for associative property is not being satisfied for subtraction and division. Okay, now coming to the distributive property. In this distributive property, we have only multiplication over addition and multiplication over subtraction. We don't have multiplication separately and division also. Okay, only these two will be applicable, that is addition and subtraction. Okay, now see, we have taken again three numbers, three rational numbers. Okay, after taking three rational numbers, we substituted them and solved b plus c value. So we got 10 by 8 as the answer. Now we did a into b and a into c separately. See here we did separately. So you got 3 by 8 and 7 by 8. When you solved it, again you got 10 by 8. If you observe, a into b plus c is equal to a into b plus a into c. So when you got the same answers, we can say that this property, this distributive property is being satisfied in multiplication under addition. The same way you are going to do for subtraction also. Here also you will get the same answers. Then you can say that this multiplication property is being satisfied for subtraction. Okay. Next, let us see the table. See, in associative property, addition and multiplication got satisfied. Subtraction and division did not satisfy. Whereas for distributive property, we only have addition and subtraction. This multiplication and division is not applicable. Next one is role of 0. When you add 0 to any number, its value doesn't change. For example, if you can see that you are adding 0 to 12. So, what happens? The same number 12 you got. Again, when you add 0 to x, the same number x you got, like that. Whenever you add 0 to any number, its value doesn't change and the same number you are going to get. So, 0 is called as the additive identity. Next one is the multiplicative identity. When you multiply 1 with any number, with 12 I multiplied 1, with x I multiplied 1, with 6x I multiplied 1, you will get the same numbers. See, which number you have taken, you will get the same numbers. So, this 1 is called as a multiplicative identity. Next one is a properties. The additive inverse property tells us to simply take a number and add its opposite so that we get 0. Means the opposite number is nothing but the changing the sign and writing the same number. For example, for minus 2 the opposite number will be plus 2. For plus 2 the opposite number will be minus 2. For minus 1 by 2 the opposite number will be plus 1 by 2. Understood? So just add the number which is opposite of that number and you should be getting 0 as the answer. So here if you can observe that 6 is the additive inverse for minus 6, whereas minus 6 is the additive inverse for 6. That is because when you are going to add both of those numbers, then what happens, you are going to obtain 0 as the answer. So both of them are called as the additive inverses of each other. Next one is called as a multiplicative inverse. What is called multiplicative inverse? The reciprocal of the given number is called as a multiplicative inverse. That is one definition, or else you can say that when you are multiplying two rational numbers, if you get 1 as the answer, then both of the rational numbers are called to be as the multiplicative inverses of each other. For example, you can see that 5 by 3 reciprocal is 3 by 5. When you are multiplying these two numbers, you are getting 1 as the answer. So, both these numbers, that is 5 by 3 and 3 by 5, can be called as the multiplicative inverses of each other. Or else we can say that multiplicative inverse is nothing but the reciprocal of the given number. So, reciprocal for 5 by 3 is 3 by 5. So, 5 by 3 reciprocal is 3 by 5, right? So, the multiplicative inverse of 5 by 3 is 3 by 5, whereas the multiplicative inverse for 3 by 5 is 5 by 3. Next one is, how do we find infinite numbers which are present between two given rational numbers? See, if he has given you to find the rational numbers which are lying between 3 by 8 and 7 by 8. See, here you can see only 3 numbers, but he asks you to find out 5 rational numbers or 10 rational numbers which are lying in between 3 by 8 and 7 by 8. Then how will you do is, just multiply the number which you are given with. The question you are going to multiply with any same number like 10, like 20, like 11, like that you are going to multiply the numbers. Then you will get 30 by 80 here and 70 by 80 here. Actually, we multiplied it directly because here both are having the same denominators. When you have like denominators, then you can multiply just like this. Otherwise, you have to make the denominators into the like in the form of like denominators, and then only you have to multiply. Anyway, that one also I will say you in the next problem. Okay, so the rational numbers which are lying in between these two numbers, that is between 30 by 80 and 70 by 80, are called as the rational numbers which are lying in between 3 by 8 and 7 by 8. Here the answer will be 31 by 80, 32 by 80, 33 by 80 till 69 by 80. Among these numbers you can take any 5 or 10 rational numbers depending upon the question. Next one is here you can say that you can see that 5 rational numbers he asked us to find out between minus 3 by 2 and 5 by 3. So when you are given with different denominators like this, then what you will do is the second number's denominator, that is with 3 you are going to multiply the first number numerator and denominator. See, we have done here, then you got minus 9 by 6, whereas the second number for 5 by 3 you are going to multiply numerator and denominator with the first number's denominator, that is with 2. When you multiply, you will be getting the answer as 10 by 6. So you can observe that the rational numbers which are lying in between minus 9 by 6 and 10 by 6, like minus 8 by 6, minus 7 by 6. Imagine number line so that you will get the numbers minus 6 by 6, minus 5 by 6, minus 4 by 6, minus 3 by 6, minus 2 by 6, 1 by minus 1 by 6, 0 by 6, 1 by 6, 2 by 6, so on till 9 by 6. All these numbers are the rational numbers which are lying in between minus 3 by 2 and 5 by 3, we can say. So any 5 numbers randomly you can take and write, or else sequentially you can take and write. Next, let us discuss about the rational numbers. Exercise 1.1. Okay, so here first question is, using appropriate properties find minus 2 by 3 into 3 by 5 plus 5 by 2 minus 3 by 5 into 1 by 6. First, when you have multiplication symbol, those becomes as one set. Okay, here minus 2 by 3, 5 by 3 by 5. Here 3 by 5 is there, here also 3 by 5 is there. So bring those two terms to one side. See, here I have brought both the two terms, first term, second term, and left over 5 by 2. Here I have brought it. Now let us see what you are going to do. See here, if you observe, the same numbers are there. So we can write as A into B minus A into C formula, but A value should be same. So what you will do, you just interchange 3 by 5 to the other side. Why? Because 2 by 3 into 3 by 5 is same as 3 by 5 into 2 by 3, right? So that's why I interchange. So it became in the form of distributive property. Using distributive property, I got this answer, and when you solve it, you will be getting 2 as the answer. Okay, the second bit also same method you are going to do. When he asked you to find out the additive inverse, what is additive inverse for 2 by 8? It will be minus 2 by 8. Additive inverse is nothing but what I said, you just the symbol you are going to change, just the sign you are going to change, negative to positive and positive to negative. Okay, so now see the fourth bit, 2 by minus 9. Minus, it can be written either in the numerator or denominator place. So plus 2 by 9 will be your answer. Understood? Like this you are going to solve. See third bit, minus 6 by minus 5 is the question. If you solve it, you will be getting 6 by 5. So 6 by 5 is the question he has given. What is the additive inverse of this? Minus 6 by 5. Understood? Like this we are going to solve the additive inverses problems. Next one is, verify that minus of minus x is equal to x for x is equal to 11 by 15. So minus of minus x is equal to x, that is what we need to prove. First take LHS, then take RHS. When you find out that LHS is equal to RHS, then you can write that hence proved. Okay, first he has given that x value is equal to 11 by 15. So minus of minus 11 by 15, when you solve, you will get minus into minus s plus 11 by 15 will be your answer in LHS side. Whereas in RHS side, already x value it is given like 11 by 15. So you can observe that LHS and RHS got the same answer, and so hence verified you can write. Next is the fourth question. Find the multiplicative inverse of the following. Multiplicative inverse is nothing but the reciprocal of the given number. I said you. What is multiplicative inverse for minus 13? 1 by minus 13. Why? Because minus 13 can be written as minus 13 by 1. No, so its reciprocal will be 1 by minus 13. Like the second bit answer is 19 by minus 13. Third bit answer is 5 by 1. Just the reciprocals, means numerator to denominator and denominator to numerator you will get. Now see the fourth bit. Minus into minus becomes plus. 5 3s are 15 by 8 7s are 56. So this is a given question. What is the multiplicative inverse of this? 56 by 15. This is your answer. Okay, like this you are going to solve the problems in this chapter. Next one is exercise 1.1, sixth problem. Multiply 6 by 13 by the reciprocal of minus 7 by 16. What is reciprocal for minus 7 by 16? It is 16 by minus 7, right? So multiply it with 6 by 13. So what is the answer you are going to get? Minus 96 by 91. If you place this minus in the numerator or denominator, its value doesn't change. Both will give you the same answer. Next one, find 10 rational numbers which are lying in between minus 2 by 5 and 1 by 2. How you will solve it? Minus 2 by 5 and 1 by 2 I have written. They are having unlike denominators, so make them into like denominators by multiplying with the other number, with the second number's denominator, both for the numerator and denominator here, and the same method you will follow here also. See, I multiplied with the first number's denominator for the numerator and denominator here. So, I got minus 4 by 10 and 5 by 10 as the answers. Okay. So, what will lie in between minus 4 by 5, minus 4 by 10 and 5 by 10? Minus 3 by 10, minus 2 by 10, minus 1 by 10, 0 by 10, 1 by 10, 2 by 10, 3 by 10, 4 by 10. But actually how many he asked us to find out? 10. 1, 2, 3, 4, 5, 6, 7, 8. Only 8 numbers we got. So what you have to do? Now again multiply the answers which you got with some other numbers. Like see 11 by 11 and 11 by 11 I multiplied. The only rule is the denominators of both the numbers should be same. So we got the denominators as 110 and 110, right? Minus 44 by 110 and 55 by 110. So the numbers which are lying in between them, like minus 43 by 110, minus 42 by 110 till 54 by 110 we can write. So among these any 10 rational numbers you can take. Okay. So this is about the rational numbers chapter. Thank you.